So this video is just going to go over Gay-Lussac's law real quickly and do a couple of the problems on that. However, we're using so much of the same format as the other two laws that we've learned so far, Boyle's law and Charles' law, that this one will sort of come across as a no-brainer. If you remember Boyle's law, all right, that law was P1 V1 equals P2 V2, right? So just the relationship between pressure and volume. And we said that this relationship was an inverse relationship, right? And we drew it like that to say when one goes up, the other goes down proportionally, right? So that's inverse. The next law that we learned was Charles's law. And if you remember that one was volume and its relationship with temperature. And what we said was volume is always going to be liters, of course, but temperature always has to be K, right? We can never work in C. We've always got to do the conversion over. So these were the first two laws that we have learned. We've got one more law, and it's very much related to these. And as you might guess, it involves pressure and temperature and their relationship. And this relationship is also really straightforward. It's just pressure over temperature. P1 over T1 equals P2 over T2. All right? And what we see when we have this is Boyle's law was inverse, Charles's law, and Gay-Lussac's laws are both what we call a direct relationship. So when one goes up, the other goes up. And that's the way that they interact. Okay? So you can probably guess exactly how we do these. It's the same exact way. Number one, the first thing we do is we write our answer label. So if at this point you haven't already printed out your problem sheet, go ahead and get it printed out. And we know our first step is we write our answer label, right? Our second step is that we identify all the variables. The third step is that we go ahead and we convert anything that needs to be converted. So we've got temperature as this. Temperature has to be in K, Kelvin, if it's not already. Now pressure, if you remember, we learned 3 different values for pressure. But those pressures, no matter which ones you use, are going to work just fine. So you don't need to do any pressure conversions on this. Just convert if it's Celsius to Kelvin. That's all you have to do. All right, and then we do our isolate the variable to be found, right? Oops, I'm sorry. I was writing and it wasn't on the screen. There we go. So write our answer label, identify the variables in the word problem. If we need to convert to K, we convert Celsius to K. We isolate the variables to be found, and then we just populate and compute. And then number 6, just if needed, we'll go ahead and convert back to Celsius. But the only reason to do that would be if they explicitly ask for an amount in Celsius as part of the answer. Otherwise, we don't need to work with that, do we? All right, so let's do some of these problems together. So answer label. What will the final pressure? So I'm going to write P2 right over that. And over here, I'm going to write P2. And I know it's going to be blank. And then my answer label. My pressure is initially expressed in atmospheres. It doesn't ask me for kilopascals or for millimeters of mercury or torr. So therefore, I'm just going to have atmospheres as my final answer label. All right, then I identify all my variables. So pressure of 1 atmosphere is my P1, right? 10 degrees Celsius, that is my T1. And then my T2 is 110 Celsius. All right, so now I've got all my variables. Now, do I need to convert anybody? Yep, I do, because I've got Celsius here. 10 degrees Celsius, 10 plus 273, 283 K. 110 degrees Celsius, that's going to be equal to 383 K, right? All right. So now I need to isolate the variable to be found. So I remember my general law is P1 over T1 equals P2 over T2. And so I need to find P2. So this is going to be pretty simple. I will just, here, I'll rewrite the whole thing here. So all I need to do to find P2 is multiply both sides by T2. Cancels out. Now I've got an isolated variable. So let's populate this guy. T2, I said was 383 degrees Kelvin times P1. P1 was 1 atmosphere. That's awfully easy. All right, over T1. T1 was 283 degrees Kelvin. And when I do the math on this little guy, I get 1.35. So I'm going to say 1.35 atmospheres for my answer on that one. Let's do the next one. Okay, so what pressure equals blank, and I'm in atmospheres again, aren't I? So that's P2. All right, let's identify my variables. There's P1, there's T1, and there's T2. All right, so now let's see, convert to Kelvin. I do have to convert this guy to Kelvin, don't I? And that's going to be plus 273, so it's going to be 298 Kelvin. Okay, now that's already in Kelvin, so I'm good. All right, so P1 over T1 equals P2 over T2. I'm looking for P2, same exact thing, right? All right, so now I've got isolated variable. Now let's populate. T2 is 3 degrees. My goodness, that's almost absolute zero, isn't it? That's incredibly cold. P1 is 1 atmosphere over, and then T1 is 298 degrees Kelvin, and that comes down to equals 0.01, 0.01 atmosphere. That poor astronaut. How'd you like to be the first guy who ever did a spacewalk and wore a spacesuit? That must have been completely terrifying. All right, so what do we have here? We've got the same thing. We're looking for P2. So P2 and then equals blank kilopascals. Okay, so there's P2. Okay, and I know I've got this formula to use T2 times P1, right? What we saw up there. Okay, if initial temperature is room temperature is 25 degrees Celsius. So therefore it is 298 degrees Kelvin. Okay, ending temperature, oh my gosh, 928 degrees C. Oh, this is going to be incredible. Okay, so to get to Kelvin, remember what we have to do? 0 degrees Celsius is 273 degrees Kelvin. So therefore, to get this to Kelvin, I've got to add these two up. So that's 11, 0, 1101. Is that right? Did I do that right? No, I didn't. It needs to be 1201, doesn't it? Yep, 1201 Kelvin is my temperature. So there's my initial pressure, my P1. So now let's do this. T2, let's see. So this is T1 and this is T2. So T2, 1201 Kelvin times P1 is 1 atmosphere. Is 298 K is my T1, right? And when I do the math on this, I come out with 4.03 atmospheres. So that's why I always put the labels in these equations, is I want to get this to atmosphere. I want to be sure that I don't lose a label here. So I'm in atmospheres. I have to convert that to kilopascals. So do you remember how to do that? 4.03 atmospheres times, atmospheres is going to be in the denominator. 1 atmosphere equals 101.3 kilopascals. And therefore my answer is 408.239 kilopascals. So I'm just going to write 408 kilopascals for my answer there. Okay, so same thing exactly. Let's see. What is the pressure? So here is again, we've got P2. Same formula as always, T2 times P1 over T1. Um, so here is my P1, and here is my T1. There's my T2. All right, the next thing I need to do is I need to convert these guys that are Celsius to um, Kelvin. So plus 273 would be 314, plus 273 would be 295 K. All right. All right, so I'm ready to go. T2, 295 K times P1. P1 is 108 over, and then I get to 41 degrees, which is 314, right? Okay, when I do the math on this guy, I come out to 101.46 kilopascals. All right, because my K's cancel out. All right, now the next problem, whoops, sorry, here it is. Next problem that we need to look at is one where we are not asked for pressure, are we? We're asked for temperature. So that's going to be T2. And remember what our formula is. It's P1 over T1 equals P2 over T2. And be sure that you know for the quiz, how do you find this? How do you isolate T2? So let's do that real quick before we do anything else. First of all, we multiply both sides by T2. All right, and when we do that, now we've got T2 in a numerator, but it's still not isolated, is it? So now I need to multiply this by the reciprocal of P1, T1. So I need to multiply it by T1, P1 on both sides, right? And when I do that, my P1 crosses out here, my T1 crosses out here. And now I've got, it's a mess, so I'll rewrite it. Equals P2 over T1 over P1. So first step is get whatever you need to isolate into the numerator. Then if anything is remaining here, to isolate it, you generally have to multiply by the initial reciprocal, the reciprocal of the initial. All right? So let's go on now that we've got our formula. Let's identify everything that's here. Let's see, what is the temperature of the air in the tire? So we're going to have equals blank. And then notice I didn't say C or K, so I can just keep it in K. If I'm feeling lazy, I could translate it back to C. So let's now go in and identify everything. Pressure in a car tire is, here's my P1, here's my T1. After a long drive, the pressure is, so here's P2. Okay, both are kilopascals. Here I've got degrees C, so now I've got to translate this. 27 degrees plus 273 degrees is 300 degrees. Right? Right. And so my formula is going to be P2, so 225 kilopascals times T1, which is 300 degrees, over P1, which is 198 kilopascals. So I'm going to end up with K. That's a good thing. When I do the math on this, I get to 340.9 K. So I'm going to round it. 341 K is my answer on that. All right, one last one. Let's do this real quick. What is the ending temperature in Celsius? So my answer is going to be blank C, and I know that I'm looking for T2. All right, T2. So initial temperature is room temperature. I know that that's 25 C. So, and I know I'm going to have to translate that. This is T1. I'm going to have to translate that. So that'd be 298 K. Okay. Pressure changes from 1 atmosphere. So there's my P1 to 228 kPa. Oh my gosh, look what they're doing here. Atmospheres and kPas. So I know that 1 atmosphere is 101.3 kPa. I'm going to cross that out to 228 kPa. So that is P2. What is the ending temperature in Celsius? So I'm using the same formula here. So not to reinvent the wheel, I'm just going to write it down again. All right, now let's populate it. P2 is 228 kPa times T1, which is 298 K, all right, over P1, and P1 is 101.3 kPa. All right, my kPAs translate out, and there I've got, when I do the math, I end up with 670.7 K kelvins. Sorry, that looks sort of bad, doesn't it? And to translate kelvins into centigrade, I just have to subtract out 273. And when I do that, I get 397.7 degrees centigrade. And so I'm going to say 398 centigrade. So that's all it is.